binomial expansion for n negative integer or fraction. For the binomial expansion 1 plus x to the power of n, where n is negative integer or fraction, we use the following expansion. 1 plus x to the power of n equals to 1 plus nx plus n multiplied by n minus 1 over 2 factorial multiplied by x squared plus n multiplied by n minus 1 multiplied by n minus 2 over 3 factorial multiplied by x cubed plus triple dots. These triple dots indicate this series is an infinite series. This expansion is valid for absolute x less than 1, or we can write as x in between -1 and 1. If the expansion is written in the form of 1 plus ax to the power of n, then the expansion will be 1 plus ax to the power of n equals to 1 plus n multiplied by ax to the power of 1 plus n multiplied by n minus 1 over 2 factorial multiplied by ax whole squared plus n multiplied by n minus 1 multiplied by n minus 2 over 3 factorial multiplied by ax all cubed plus triple dots. This expansion is valid for absolute ax less than 1, where you can write as x in between -1 over a and 1 over a. Example 3. Expand 1 plus 3x to the power of 1 over 3 in ascending powers of x until and including the term x cubed. By substituting x equals to 1 over 1 to 5, find the value of cube root 2 to 5 decimal places. There are a few things you need to check before you expand binomial expansion for negative integer or fraction. The first one, the constant must be 1. So in this case, this constant is already 1. Then, you need to check how many terms involved. In this question, you need to expand up to the term x cubed. Now, let's start. From this one, we notice that our n equals to 1 over 3 and our ax equals to 3x. Apply the formula where 1 plus 3x to the power of 1 over 3 equals to 1 plus 1 over 3 multiplied by ax is 3x plus 1 over 3 multiplied by 1 over 3 minus 1 over 2 factorial multiplied by 3x squared plus 1 over 3 multiplied by 1 over 3 minus 1 multiplied by 1 over 3 minus 2 divided by 3 factorial multiplied by 3x all cubed plus triple dots. Now, use your calculator and calculate each term correctly. So the first term is 1. This is equals to 1. Second term, 1 over 3 multiplied by 3x. This is equals to plus x. So, plus x. Next term, 1 over 3 multiplied by 1 over 3 minus 1 divided by 2 factorial multiplied by 3 squared multiplied by x squared. This is equals to negative x squared. Next term, 1 over 3 multiplied by 1 over 3 minus 1 multiplied by 1 over 3 minus 2 divided by 3 factorial multiplied by 3 cubed multiplied by x cubed. This is equals to plus 5 over 3x cubed plus triple dots. So this is the expansion when you expand 1 plus 3x to the power of 1 over 3. Now, substitute x equals to 1 over 1 to 5 into your expansion for both sides. Meaning, you need to substitute x equals to 1 over 1 to 5 into this x, this x, this x, and this x. Now, your expansion will be 1 plus 3 multiplied by 1 over 1 to 5, the whole thing to the power of 1 over 3, equals to 1 plus 1 over 1 to 5 minus 1 over 1 to 5 all squared plus 5 over 3 multiplied by 1 over 1 to 5 all cubed. When you simplify the left side, you will get 1 to 8 over 1 to 5, the whole thing to the power of 1 over 3. And then, when you simplify the right side, you will get 1.007937. Remember, the question asks you to find the value up to 5 decimal places. So, for this side, we need to take extra 1 decimal places first. Next, we need to split 1 to 8 into 64 multiplied by 2 over 1 to 5, the whole thing to the power of 1 over 3 equals to 1.007937. Maybe some of you might ask, why do we need to split 1 to 8 into 64 multiplied by 2? Okay, this is because we need to make sure the value of 2 appear on the left side. Remember, the question asks you to evaluate cube root of 2. Cube root of 2 also equals to 2 to the power of 1 over 3. Okay, is it clear? Alright. Next, you can simplify the left side by using rules of indices, where it is equals to 64 to the power of 1 over 3 multiplied by 2 to the power of 1 over 3 over 1 to 5 to the power of 1 over 3 equals to 1.007937. Next, 64 to the power of 1 over 3 is equals to 4 multiplied by 2 to the power of 1 over 3 is 2 to the power of 1 over 3 over 1 to 5 to the power of 1 over 3 is 5 equals to 1.007937. After that, you need to leave 2 to the power of 1 over 3 as a subject. So, 2 to the power of 1 over 3 equals to 5 over 4 multiplied by 1.007937. So this is equals to 1.25992, correct to 5 decimal places. So this is the answer. Example 4. By using binomial expansion, expand 1 over 2 minus x all squared in ascending power of x until the term x cubed. Hence, state the range of values of x for the expansion to be valid. B. Find the value of 1.9 to the power of negative 2, correct to 3 decimal places. Now, let's discuss how can we solve this question. First, you need to rewrite 1 over 2 minus x all squared as 2 minus x to the power of negative 2. And then, from this question, we notice that this constant is not 1. So, we need to change into 1. Therefore, it is equals to 2 to the power of negative 2 multiplied by 1 minus x over 2 to the power of negative 2. From this information, we know that our n equals to negative 2 and our ax equals to negative x over 2. Substitute all the information into the formula, which is 1 over 4 multiplied by 1 plus negative 2 multiplied by negative x over 2 plus negative 2 multiplied by negative 2 minus 1 over 2 factorial multiplied by negative x over 2 squared plus negative 2 multiplied by negative 2 minus 1 multiplied by negative 2 minus 2 over 3 factorial multiplied by negative x over 2 all cubed plus triple dots. Then calculate 1 over 4 equals to 1 plus negative 2 multiplied by negative x over 2 is equals to x. Negative 2 multiplied by negative 3 divided by 2 factorial multiplied by negative x over 2 squared equals to plus 3 over 4 x squared. And for the last term, negative 2 multiplied by negative 3 multiplied by negative 4 divided by 3 factorial multiplied by negative x over 2 all cubed equals to plus 1 over 2 x cubed plus triple dots. Expand and simplify, you will get 1 over 4 plus 1 over 4 x plus 3 over 16 x squared plus 1 over 8 x cubed plus triple dots. So this is the expansion for 1 over 2 minus x all squared. Next, you need to state the range of values of x for the expansion to be valid. In general, the expansion is valid for absolute ax less than 1. In this question, our ax equals to negative x over 2. Therefore, absolute of negative x over 2 less than 1. Absolute of negative x over 2 also equals to absolute of positive x over 2 less than 1. Therefore, your x in between negative 2 and 2. Next question, you need to find the value of 1.9 to the power of negative 2 correct to 3 decimal places. Recall the expansion from the previous slide where we have 2 minus x to the power of negative 2 equals to 1 over 4 plus 1 over 4 x plus 3 over 16 x squared plus 1 over 8 x cubed plus triple dots. 1.9 to the power of negative 2 is equals to 2 minus 0.1 to the power of negative 2. When we compare, we notice that our x is equals to 0.1. Substitute x equals to 0.1 to both sides. You will get 1.9 to the power of negative 2 equals to 1 over 4 plus 1 over 4 multiplied by 0.1 plus 3 over 16 multiplied by 0.1 squared plus 1 over 8 multiplied by 0.1 cubed plus triple dots. Calculate, you will get 0.277 correct to 3 decimal places. So this is the answer when you evaluate 1.9 to the power of negative 2. As a summary, in this lesson, you had learned how to expand 1 plus ax to the power of n by using this formula. Before you expand, you need to make sure the power must be in negative integer or fraction. Then, this constant must be 1. The next one, you need to know how to find the interval of x valid for by using absolute ax less than 1. And the last one, you need to know how to approximate the value. In order to approximate the value, substitute the given x into the expansion for both sides. After that, simplify and evaluate. Make sure you give your answer correct to instructed decimal places or significant figures.